Hi students, in this part I'll be telling you about various organic chemistry reactions, mechanisms. So what actually is happening that just like inorganic chemistry, here also there are some substrates, there are some catalysts, there are some attacking reagents, we say attacking reagents, and this is the way they form the product of my organic compound product. That we'll be learning here. So let's proceed. Now we're going to learn some of the organic reaction mechanism, guys, okay, which are very important functions, which many like the way in inorganic chemistry we have chemical reaction, or in the redox reaction I have redox chemical balance reaction, right? In a similar way, in organic chemistry we have reactions, but there are many different mechanisms for every kind of reaction. So what are the reagents we take, okay, what are the types of reaction in organic chemistry, that we're going to learn here. So in an organic reaction also I have a attacking reagent, okay, attacking reagent which attacks on my substrate to give me the final product. It's like this: organic molecule, the substrate, I have attacking reagent, then there is an intermediate formation takes place. Intermediate get formed, okay, this gets formed, and which further gives me my products or byproducts. So substrate is what it is that reactant which supplies the carbon to the new bond, because the attacking reagent, it does what? It does bonding with the carbon which is already present in the substrate. And reaction mechanism, if you check out, then there will be a sequence step, okay, that first of all your attacking reagent is coming closer to the substrate, and then some polarity is getting changed, the electron cloud is getting diversified, okay, there is polarity of electron cloud there, and then there is bond breakage, and then the new bond formation takes place. So these all involve the chemical kinetics, okay, reaction mechanism. Now cleavages are of the two types, heterolytic and the homolytic. So now we are going to learn the fission of a covalent bond, heterolytic cleavage. So heterolytic cleavage is what? It is the one which is in a fashion that the shared pair of electron remains with only one of the fragments. Like here, if you see CH3Br, out of these two groups, Br is the more electronegative than your CH3. So your electrons will shift to Br. Electron will shift to Br and it will acquire Br negative and CH3 positive. And species having sextet of electrons and a positive charge, that is known as what? Carbocation. So there the CH3 positive which was obtained, that was what? Carbocation. That was nothing but carbocation or carbonium ion, okay. And the stability of carbocation is what? Your tertiary is the most stable, then your secondary, then your primary, okay, then your, this is 0 degree, yeah, 0 degree. So this is your tertiary. Tertiary means what? This carbocation has been attached by three other carbons. Like why this is more stable? Because I have this C plus, okay, and I have 3C here, okay. And these methyl groups are what? They are electron donating groups. So they will donate their, means in a bond we feel like that in the sigma bond they donate the electrons, and if they donate, then obviously this positive charge which is obtained on that C plus, that will get balanced. So that's why they are the more stable tertiary carbocations. And the organic reaction which proceeds to the heterolytic cleavage are known as what? Ionic or the heteropolar reactions, ionic reactions, okay. Ionic reaction now in organic chemistry. Now homolytic. Homolytic is, it will be like what? It will be like two similar kind of atoms, okay, two similar kind of atoms. Like if you have Br2, okay, then Br and Br. So I will be having half here, half here, and they both will acquire what? Electron over it. They are known as what? Radicals, free radicals, okay, free radicals which have unpaired electrons. And your organic reaction which proceed by homolytic fission, they are your free radical reactions or the homopolar reactions or the non-polar reactions like this. Okay, what actually is happening here, your X and your R is not having that much electronegativity difference. That's why it is showing me the homolytic fission. Then comes the nucleophiles and the electrophiles, guys. So nucleophile is what it is, any species, okay, I'll give you very simple definition. It is any species which is having a negative charge on it. A region that brings an electron pair, nucleus seeking, is a nucleophile. So these are having what? Nuclear charge over it. And electrophile is having what? Positive charge over it. That's it. Nucleophile and electrophile. Then the way they will attack, obviously, if my nucleophile, which is a negative one, it will try to do what? It will try to find out the positive center in the carbon one, in that parent chain, right? It will try to find out the positive center. And the electrophile one, this will try to find out the negative center, which it will get from the oxygen atom which is present there, or any electronegative atom which is present there. Now, electron movement in the organic reactions. So they are like this way. Like here, I have a double bond and a single bond. It can be also the case that these two electrons, they break up, okay. I'll show it here. The electrons which are present here, okay, in this bond, okay, there are two electrons. So this will get break up and they will get transferred to this single bond, and now it has acquired this configuration. So from pi to the adjacent bond position also movement takes place. Similarly, from pi to the adjacent atom, like this way also bond takes place, means to the adjacent bond earlier it was showing, now it is to the adjacent atom. So your Y will get those two charges, those two electrons. And then from atom to the adjacent bond position, means from atom also I can get my double bond formation like this way. So these are the three electronic movements in the organic reactions. Movement of the single electron is indicated by a single barbed fish hooks. So these are what, if I draw single electrons, so fish hooks are like this way, I will tell you, like this way, okay, like this way, or it transfer here like this way, they're like this way, fish hooks. Then electron displacement effects in the covalent bond. How does it affect? So what happens, whenever this displacement takes place, then the electron cloud in a covalent bond, it gets shifted somewhere here and there, and that makes it a kind of unstable, which results in resonance effect, inductive effect, electromagnetic effect, mesomeric effect, and all. So resonance structure you have already studied in chemical bonding chapter, what is resonance. So here also you will be having plus R or minus R kind of thing. What happens whenever a single Lewis dot structure is not able to represent by a particular structure, then we try to represent that thing by 1, 2, 3 or 4, how many types it can take in those all structures, okay. And we say that those all are what? Canonical forms. And out of them, if I combine all of them, I'll get a more stable structure, that is my resonance hybrid structure. And the difference in the energy between the actual structure and the resonance, the lowest one, is your resonance stabilization energy. Okay, resonance energy or the resonance ionization energy, stabilization energy. That is a difference. And these are the rules which are applied to the resonating structures, that your resonating structures, they have what? Same position of the nucleus, means the central atom will be the same, and same number of the unpaired electrons. Only it will be getting transferred here and here. Other thing will be the same. So by resonant effect, what do I mean? It is actually defined as the polarity which is produced in a molecule by interaction of two pi bonds or between a pi and a lone pair. Okay, like there I was having that electron transfer between atom and the bond. Suppose I have Y negative and I have transferred this to this. Okay, suppose I have Y double bond, it get transferred to this. So these are what? These are the resonance effect. Now this can be plus R or minus R. So in plus R, what happens? Transfer of the electrons is away from the atom. Okay, it is away from the atom, like this way. This is a plus R case. Okay, away from the atom or substituent which is attached to a conjugated system. And in the negative R, it is observed when the transfer of electron is towards the atom or substituent group attached to the conjugated system. That is my negative R. That is my negative R. Then comes the inductive effect. This is very easy effect. Okay, the ones which are electron donating, okay, they will, we say that they donate in a sigma bond kind of thing. Okay, like here, if I draw this structure, okay, so this carbon can also donate this one, this carbon can also donate this. So carbon CH3 group are what? Electron donating one. So this is your inductive effect, this is your inductive effect, this is your plus I effect, plus I effect. So the process of electron displacement of electrons along the chain of the carbon or the sigma bonds, we say, they are of the polar, not popular, they are the polar covalent bond. Okay, polar covalent bond at one end of the chain. And this is a permanent effect, okay, shown by the arrow which I have shown like this. You can also say, like here I have Cl which is more electronegative, so obviously this will be delta negative. So a partial positive is attached on the CH2 plus. Okay, here we attain the partial positive. And then as CH3 is even more at a larger distance than Cl negative, so that will occur the positive charge, but that is very less. So delta plus charge. So it decreases sharply as you move away from the electronegative element or the more polar element. Then we have plus E effect, guys. Okay, it is what? It is the complete transfer of the electron of the shared pair of pi electron to one of the sigma bond by the demand of the attacking region. So what happens? Your attacking region is coming, it needs a positive core or a negative core. Okay, it can be either a nucleophile or a electrophile, so obviously it will need a positive center or a negative center. So in doing that, what happens? It breaks the bond and it gives to the side atoms or side bonds. So that is your plus E effect. So in this effect, the pi electrons of the multiple bonds are transferred to that atom to which the reagent gets attached. Now if those electrons are getting to that atom to which my reagent will also attach, then I will say that it is my plus E. If that electron are transferred to those atoms to which my attacking region will not attach, so that will be my minus R. Here you can see that the H plus here is the attacking reagent, okay, and when it came, okay, this electron, this pi bond electron, it get transferred to this carbon atom, it's formed the carbocation here and carbanion here, right, and H plus is attacking to this. So we will say here that, okay, I am having a plus E effect, negative E effect when they are transferred to the other atom, So these are all the important reaction mechanism in organic chemistry, okay. So we learn the resonance, we learn the electromagnetic effect, we learn the inductive effect, we learn the fission, fusion, homolytic, heterolytic. So these are very conceptual things in the organic chemistry. Just like the inorganic chemistry, here I have these mechanisms working under. So it depends upon the attacking reagent, it depends upon the substrate, it depends upon the steric hindrance, okay. We'll talk a lot about it. So students, in this part, we saw that there is some attacking reagent, and according to that, my substrate, it changes. It either give me a carbocation or a carbanion, and for the stability purpose, it gives me the product. That is the best way to remember that how does a reaction follows. Also, we saw that there is cleavage reactions here, right? Cleavage reaction, homolysis, heterolysis and all. Now, with respect to the stability, there is one more factor. Which I'll be discussing in the next part. That is known as hyperconjugation. So stay tuned with me for that.